Hello, students. Had a question come in about one of these things on page 760. This is about the rectangle. Remember, a rectangle is a parallelogram with a right angle. So we need to show this last one, quadrilateral, where the diagonals are congruent and bisect each other, is a rectangle. That's our goal. So we are going to, we're just going to make some white space here, probably. Shoot, I don't even have my little tool. Okay, so we're gonna I don't have my drawing tool at this computer, but let's see what we can do. So first off, I do not know it's a right angle. I do not know it's a parallelogram, but I do know that the diagonals are congruent and they bisect each other. Okay. Now, what's so important about that? Here's why. You get guaranteed vertical angles, right? This one is the same as this one because they're vertical angles. And this piece is the same as that piece because the diagonals were bisected. But because the diagonals were congruent to begin with and bisected, that means all four of these pieces are the same. And now you know that this triangle up here on top is congruent to this one down here by side angle side. If that is true, which we just showed it is, then this angle right up here has to be congruent to this angle right over here, right? Because it's an isosceles triangle. And it also has to be congruent to this one down here by alternate interior angles, and to this one over here, either by alternate interior angles with the little part about angle C, or by the fact that the lower one is also isosceles. So corresponding parts are congruent and the angles are congruent themselves because it's an isosceles triangle. And that means BC is parallel to AD. And so now I know BC is parallel to AD. Well, all you have to do is repeat the entire argument, and except you do it with this one right here, this triangle, the light blue one, and with this blue triangle over here. Those two are going to be congruent by side angle side for exactly the same reasons. As a matter of fact, their side components are going to be exactly the same for exactly the same reasons. So this angle right up here has to be the same as this angle right down here, right? And vice versa, which is congruent to corresponding parts, CPCTC, to these over here. So what you end up with is you end up with quadrilateral, which has 360 degrees. You end up with AB parallel to CD, BC parallel to AD, which means it's a parallelogram. The interior angles, 360 degrees, but each interior angle is a black and a green. Each one. It's a black and a green. So you want to label those with X and Y, you can. So you have XY plus XY plus XY plus XY. That's 4X's plus 4Y's gives you 360. If you divide everything by 4, you get X plus Y equals 90. And 90 degrees is all we need to show why one of these has to be a 90-degree angle. That is why it's a parallelogram with a right angle, and therefore it must be a rectangle. All right. So that proves that one on 760. Again, they're all pretty similar. Do you notice what I'm doing? Every time I just take what they give me, I use it to create congruent triangles. I get free things with corresponding parts being congruent. Gotta love it. So anyway, there you go. All right. If you have other questions, let me know. Otherwise, off you go.